Hello everyone. Today we're going to be working on section 2.1, which is the beginning of functions. Now a function itself is a relationship between a set called A and a set called B. Typically we take in our set A and we have a bunch of x values, and each x value is mapped using our function to the set B. So if you were thinking about that as far as a picture is concerned, we'll call this set the set A, and this set the set B. Now within sets A and B there are a number of elements. So x1, x2, x3, and so on could be in A, where in B we have y1, y2, y3. Now the function itself, usually notated with an f or a g or an h depending on what you're looking at, is the relationship between this x value and the y values. So this part here, the bridge, is your relationship or your function. Now we have a couple names for things. The set A is called the domain, and typically those are your x values or input values. The set of y values that correspond to it are called your range, or the set of output values. Now if a relationship is a function, we are able to solve for y uniquely. So if you're looking at an equation like 3x squared plus 2y is equal to 5, if you're able to isolate y by itself on one side, then that relationship is a function. So looking at this, if I subtract 3x squared from both sides, I get 2y is equal to negative 3x squared plus 5. Dividing through by 2 to isolate y, I get y is equal to negative 3 halves x squared plus 5 over 2. So since I'm able to isolate y alone on one side, this is a function. If we want to determine if the equation x squared plus y squared is equal to 15 or 16 defines y as a function of x, same process applies. Isolate y on one side. So subtracting x squared from both sides results in y squared equals negative x squared plus 16. In order to isolate y, I'd have to take the square root. So taking the square root gives me y on one side. On the other side, anytime you take a square root of a variable, you get a plus or minus case. So negative x squared plus 16. Since we have y equal to the positive of the square root and the negative of the square root, what we have is not an isolated case. So this one, yes, is a function. This one, no, is not a function of x, since y cannot be isolated and be unique. So this value is not unique. Like I said, functions are usually represented with letters. If you're looking at it in print, it's much more common to see a letter being scripty. So a script F or a script G. Sometimes you see capital letters as well. A lot of that is common with a composition of functions, which we'll get to soon. So capital F, capital G, etc. Another common letter is H for functions. You do see H with a lot of times. So if a function is F, for f, then every x value in the domain is corresponded to what's called f of x. So f of x is a value f at x. So if we have f of x, this is a function where we're using x as the input variable. And if I have, say, x squared plus 2, then this is a function defined where x values are squared and then added 2 to them, and that's the relationship. So if you have a function, the variable x is the independent variable, and that's the input variable. The output variable is the dependent variable because it depends on what we input into the function. Sometimes we need to evaluate a function, and when we talk about evaluating in algebra, what that means is that we're going to plug a value in. So if we're going to plug in a value, what we have is f of 2 instead of f of x. And what that indicates is we're going to plug 2 in for x in the function. So f of 2 means that we're going to have take 2, plug it in for x. So I have 2 squared minus 2 times 2 plus 5. Simplifying our arithmetic, 2 squared gives me 4, minus 4 plus 5 gives me 5 total. So f of 2 is equal to 5. Similarly, if we're going to plug in -1, f of -1 would be -1 squared minus 2 times -1 plus 5. Simplifying arithmetic, -1 squared is 1. Here you end up with plus 2, so we have 3 altogether, plus 5 gives me 8. Now if I want to have f of x and I'm subtracting f of 2, then what I'm going to do is I'm going to take my original function, f of x. So f of x is equal to x squared minus 2x plus 5. That's the piece I'm going to plug in for f of x here. So simplifying, we have x squared minus 2x plus 5. If we had not already simplified f of 2, then we'd have to plug it in here. So f of 2 is equal to 2 squared minus 2 times 2 plus 5. We've already simplified that down to 5. So this is equal to x squared minus 2x plus 5 minus 5 equals x squared minus 2x. When you have something other than just one piece inside this parenthesis, we're going to plug that whole value in for x. So if we want f of x minus 2, that means everywhere there's an x, I'm going to plug in x minus 2. So x minus 2 squared minus 2 times x minus 2 plus 5. Remember that if you have a parenthesis and we're squaring it, we're going to square the entire thing. So it's not x squared minus 4. You have x minus 2 times x minus 2. I can distribute this too. So minus 2x plus 4 plus 5. Foiling out that first piece, x times x gives me x squared. Outside gives me minus 2x, inside minus 2x, so minus 4x. Negative 2 times negative 2 gives me plus 4. Minus 2x, combining the 4 and the 5, plus 9. And finally, combining like terms. So x squared minus 6x plus 13 for a total. The next part I wanted to go over is what's called the difference quotient. Now, for those of you moving on to calculus, the difference quotient will become very, very important right at the beginning. So this formula here, f of x plus h minus f of x all over h, is what we call the difference quotient. Now, in order to do that, what we do first is we plug x plus h into our function. So the f of x plus h piece is going to equal x plus h squared for x squared. And then we're subtracting 2x, so 2 times x plus h. And then plus 5. This piece here is our f of x plus h. So that's f of x plus h. Now if I am then moving on, this part, the next part in this equation is to subtract f of x. So f of x is our original function. So we want to go and we want to subtract the original function. So I'm subtracting f of x, which is x squared minus 2x plus 5. This part is f of x, or the original function. The last part of the equation is that it's all divided through by h. Now that h is going to sit there on the bottom until we get to where we can simplify it out. I'm just going to let it tag along for the ride. All right, now we have some algebra to do. So if we're moving through the algebra piece, the first thing I'm going to do is square this x plus h. Now you'll be working with the difference quotient quite frequently, so that's something that you'll get used to squaring. But an aside, x plus h times x plus h, multiplying x squared first, outer gives me xh, inner also gives me xh, so I have 2xh, and then my last is h squared. This you'll square a lot, so you'll have that down. So simplifying, x squared plus 2xh plus h squared, distributing the negative 2, minus 2x minus 2h plus 5, and I'm going to distribute this negative, so minus x squared plus 2x minus 5 all over h. Now I don't have a negative outside this parenthesis, so really I can drop those parentheses and combine some like terms. So looking at each piece, I've got an x squared and a negative x squared, so I can cancel that term. I have a negative 2x and a positive 2x, and I have a positive and negative 5. So those three terms can cancel out, or 6 altogether, and I'm left with 2xh plus h squared minus 2h on the top. On the bottom, I'm left with h, and I can factor an h out and cancel it all the way through. So really what I'm doing is factoring it out on the top, so 2x plus h minus 2, and an h on the bottom, and then I can cancel that h top and bottom. So that's equal to 2x plus h minus 2. All right. When we're dealing with functions, we have to work on domains. So a domain is really the legal values of x that you can put into a function as its inputs. When you're finding a domain, we always start with the set of real numbers. So all numbers from negative infinity to infinity. Now, if the function does not have a denominator or does not have any even numbered roots, that's where we land. So negative infinity to infinity is the domain of a lot of functions. If the equation has a denominator, the denominator cannot be equal to 0. So we have to exclude any values that make the denominator 0. Also, if there is a radical of an even degree, then we cannot have a negative number inside that. So, or any combination thereof. Radicals of odd degrees are fine. Radicals of even degrees we cannot have negative numbers in. So if I'm looking at these functions, then the first one, f of x is equal to negative x to the 5th plus 4x squared, and so on. I don't have any fractions, so no denominators. I don't have any roots. So this is an unrestricted all real numbers domain. So there are two ways to notate that. The first one is with set notation. So set notation is that your domain is all values of x. Then we draw a vertical bar, and those are the words such that x is a real number. So the scripty r means one of the sets of real numbers, and the backwards e means an element, or the scripty e means an element of. So x is one of the real numbers. The other one is called interval notation, and in interval notation we would notate this as negative infinity to infinity, which means any real number is fine. The next one has a fraction. So we have g of x is equal to 2x over x squared minus x minus 6. So since we have a fraction, we cannot have the bottom of the fraction equal to 0. So in order to figure out what values we need to exclude, we're going to set that equal to 0 and solve for x. So x squared minus x minus 6 is equal to 0. We need to factor this since it's quadratic. So my difference is -1, and I'm multiplying by it together to equal -6. So x minus 3, x plus 2 gives me 6, and with a difference of -1. This results in x equal to 3. This results in x equal to -2. Now, this is not where you stop. So a common mistake is stopping here after you solve for x. But remember, these are values that x cannot be. So we do need to still write this in a domain notation. So if you're doing set notation, the domain is all values of x such that x is not equal to -2 or 3. If you're doing interval notation, then all values from -infinity to -2 are fine. I'm using a rounded parenthesis because I cannot include -2. And then the numbers between -2 and 3 are fine. And then from 3 to infinity. Remember that when you're doing a interval notation, parentheses means not including. Versus brackets means that it is included. So we use brackets when we include the value. Looking at h of x next, I have x plus 3 to the 1/2 power. So as a reminder, 1/2 power is another word for square root. So that's a square root that is expressed as a power. And I cannot have a negative number inside the square root. So everything inside that square root has to be greater than or equal to 0. So solving this inequality, moving the 3 over, I get x has to be greater than or equal to 3. Again, my set notation, the domain is all values of x such that x is greater than or equal to 3. My interval notation, I'm including 3. So here I have from 3 all the way to infinity. This next one looks a little intimidating, but we have to, if we break it up, we'll see, looking at the top, this index of 3 means that it's an odd numbered root. Odd numbered roots can take any value, so I'm not worried about it at all. I am worried about the denominator, however. So remember that a denominator cannot equal 0. So we cannot have 0 on the bottom of this fraction. We also, the centerpiece has to be greater than or equal to 0 typically. Now, since it can't equal 0 because it's on the bottom of the fraction, I'm just going to take that part and I'm going to set it greater than 0. So 3 minus 2x, strictly greater than 0 since it's on the bottom. So -2x is greater than -3. And dividing by -2. Remember, for inequalities, when you divide by a negative, flip the sign. So -2x gives me x is less than 3 over 2. Set notation, x such that x is less than 3/2. Interval notation, since it's less than, we're going to -infinity. So -infinity to 3/2, not including the endpoints. Last topic for today, sum, difference, product, and quotient of two functions. So when you have functions, you can add them, subtract them, multiply them, and divide them, just like numbers. So if you are adding functions together, then the sum of two functions is the sum of f of x and g of x. We do have to consider both the domain of f of x and g of x when we add them together. Same is true for the difference, we just have a minus sign here. If we're finding the product, f times g, we're going to multiply our two functions together. And finally, the quotient, f divided by g. When you divide two functions, we're just going to divide them. But when we do the domain from a division, we have to make sure that g of x is also not equal to 0. So we have restrictions in the domain from f of x, from g of x, and from when g of x is equal to 0 there. All right, let's do an example. Let's say that f of x is negative x plus 3 and g of x is x plus 2 over x. So before we get started, I want to actually do the domain for each function. So if we're talking about this function f of x, no fraction, no square root. So this f of x domain is from negative infinity to infinity. If we're looking at g of x, I don't have any square roots, but I do have an x on the bottom. So it's just simply x on the bottom, so I cannot have 0 down there. So our domain for g of x is negative infinity to 0, not including 0, and from 0 to infinity. So if I want to determine the domain of determine f minus g of x and its domain, f minus g of x would be equal to f of x minus g of x. Now this is technically correct, but it's kind of messy. So let's try to put this into a single fraction. This first part is really over 1. So if I want to combine these two terms, I'm going to multiply my first equation or my first part by x over x just to create a fraction here. So this is like 1 on the bottom, and we're going to multiply this by x over x. Doing that multiplication, I have negative x squared plus 3x on the top. On the bottom we have x, and we're subtracting x plus 2 over x. Combining this together, bottom stays just x. On the top I have negative x squared. I have 3x, and this will be a negative x. That negative will go to both terms. So 3x minus x gives me plus 2x. And then that switches that sign, so minus 2. And there's my function. Now, since I'm subtracting, I need to take into account both domains. So the more restrictive domain is the one that we will go with here, because I still have that x on the bottom. So negative infinity to 0. And 0 to infinity. Now looking at the division of the two functions, f of x is on the top, so negative x plus 3. On the bottom we have that fraction, x plus 2 divided by x. Now I have a whole number divided by a fraction, so we need to simplify this because it's a complex fraction right now. So really this is, remember the rule that if you are dividing fractions, you hold the top one steady, flip the bottom one over and multiply. So we have negative x plus 3 on the top. It's really over 1. And I'm going to flip this and multiply. And this is really an x, not a 2. I'm going to flip this other one and multiply. So on the top, I have x. On the bottom, x plus 2. Multiplying through, negative x squared plus 3x over x plus 2. Now our original g of x function, we had to exclude 0. So we still have to exclude 0. But this new function, I also have to worry about when x plus 2 is equal to 0. So x plus 2, remember that x cannot equal 0 from g of x. And also now x plus 2 cannot equal 0. So x cannot equal negative 2 as well. So my new domain for this division of functions is from negative infinity to negative 2. -2 to 0, and 0 to infinity. If you have any questions or concerns, please reach out to me. I'd be happy to meet. And good luck on your homework for this section.